The cosmos holds far more than what our eyes can see. Scattered across the darkness are real stars that remain completely hidden from our view. In this journey, you will discover 30 of these cosmic phantoms, from rogue suns flung into the void to ancient stellar ghosts that glow with no light. We will uncover how a star can vanish inside another, and why some may be made of invisible matter. What cosmic secret are you most curious to explore? Drifting through the absolute blackness between galaxies is our first hidden star, a cosmic castaway known as a rogue star. This is a sun that has been violently evicted from its home galaxy, sent flying alone into the endless intergalactic void. Picture our own sun, a familiar anchor in our sky, suddenly ripped away from the Milky Way and set adrift in a sea of nothing. That is the lonely existence of a rogue. Why can we never see one? The distances in the intergalactic medium are so staggeringly vast that any light from a solitary star is simply too faint for our telescopes to detect. There are no nearby stars to illuminate it, no glowing nebulae to outline its form. It travels in perfect perpetual darkness, a ghost ship on an ocean we cannot chart. Its journey is one of ultimate solitude, a silent testament to the violent forces that can fling a star into the great unknown. This solitary journey begins with a cataclysm. The most common origin for these rogue stars is the violent chaos of galactic collisions. When two galaxies tear through each other, their gravitational fields become tangled and ferocious, acting like colossal slingshots that can hurl millions of stars out into the void. Another path to exile comes from a stellar explosion. In a binary star system, if one star goes supernova, the asymmetrical blast can kick its companion star with such immense force that it escapes the galaxy's grip entirely. Once cast out, the star embarks on an endless voyage through intergalactic space. This is not the relative emptiness between stars in a galaxy. This is the true void, a desolate expanse where the temperature is only a few degrees above absolute zero. There are no planets left to orbit, no asteroid belts to light up, no stellar neighbors for company. The star burns its nuclear fuel in profound isolation, its light fading into an abyss so vast that it will never be seen by another living eye. This is a sun destined to die alone, its eventual death a silent, private affair in the freezing dark. But what becomes of a star that is left to simply fade away? This leads us to a ghost from the far future, a theoretical object so cold and ancient it has never been seen. The primordial black dwarf is the final, dark state of a white dwarf star. A white dwarf is the Earth-sized core of a sun-like star that has burned out, no longer fusing atoms, glowing only with the leftover heat of its former life. It is a dying ember in the cosmic fireplace, over timescales so vast they defy comprehension. This ember slowly cools. After trillions upon trillions of years, it would radiate the very last of its warmth into space. The star would then achieve absolute zero, becoming a cold, solid sphere of crystallized carbon and oxygen. It would be a black dwarf. This object emits no light, no heat, no radiation of any kind. It is a perfect cosmic stealth object, darker than the space around it, a frozen monument to a star that once was. With our current technology, we could never detect one, for they are the ultimate cold, dark fossils of the stellar graveyard. The universe is not yet old enough for even the first black dwarf to have formed, making them phantoms of a time yet to come. Yet even the profound silence of a black dwarf is not the only way a star can vanish. Deep within the swirling chaos of a stellar nursery or the expanding debris of a supernova, another phantom can form, one of unimaginable density. A neutron star is the collapsed core of a massive star that exploded, packing more than the mass of our entire sun into a sphere no wider than a city. It is a cosmic atom, a trillion times denser than anything on Earth, where a single teaspoon of its material would weigh billions of tons. But what if this stellar powerhouse was wrapped in a perfect cloak? That is the fate of a neutron star shrouded in dust. Picture the aftermath of a supernova, a cloud of gas and dust so thick and vast it could swallow entire solar systems. If a newborn neutron star is born deep inside this opaque nebula, the cloud acts like a cosmic blanket, absorbing every form of radiation the star emits. Its powerful X-rays, its beams of radio waves, even the faint heat it radiates, all are swallowed by the immense dusty shroud. From our perspective, the entire electromagnetic spectrum goes dark. We would see nothing. This object, spinning hundreds of times per second with a gravitational field strong enough to tear planets apart, will be completely invisible, a silent, hidden heart beating inside a dark and impenetrable nebula. Even a star can fail. Littering the galaxy are cosmic in-betweeners known as brown dwarfs, objects caught in a perpetual identity crisis. They form like stars from collapsing clouds of gas and dust, but they simply do not have enough mass to ignite the sustained nuclear fusion that makes a true star shine. They are too large to be considered planets, yet too small to become suns. Imagine a ball of gas dozens of times more massive than Jupiter, glowing faintly with the leftover heat from its violent birth. This dim, ruddy glow is primarily in the infrared spectrum, invisible to our eyes and incredibly difficult for our telescopes to spot against the cold darkness of space. There are the hidden ghosts of stellar nurseries, often passing unseen right through our cosmic neighborhood. We only find them by their subtle, telltale signatures, a faint warmth detected as an infrared whisper or the slight gravitational tug they exert on a brighter, visible star they might orbit. These failed stars are a constant, dim reminder that the line between a planet and a star is far blurrier than it seems. Some stars are not hidden by darkness, but by light. Deep within the hearts of certain distant galaxies lies an engine of such ferocious power that it can outshine every single star in that galaxy combined. This is a quasar, the active supermassive black hole at a galaxy's core, and its brilliance creates a wall of pure energy that completely obscures any suns caught behind it. Imagine trying to see a single candle flame that has been placed directly in front of the blinding beam of 1,000 searchlights. The sheer, overwhelming glare erases the candle from existence. This is the fate of a star living in the shadow of a quasar. The quasar's light is not just visible starlight, it is a torrent of radiation across the entire spectrum, from X-rays to radio waves, all generated by an accretion disk of superheated gas and dust spiraling into the black hole at nearly the speed of light. Any star positioned on the far side of this cosmic maelstrom from our line of sight is simply washed out. Its unique signature, its subtle color, its very existence is lost in a blaze of glory, permanently hidden behind a curtain of pure, undiluted power. This stellar obscurity is not a matter of distance or technology, but of overwhelming contrast, a reminder that in the cosmos, the brightest lights can create the deepest shadows. But what if a star could be built from a substance we cannot even define? This brings us to the most speculative phantom of all, a star made not of the familiar atoms that compose our world, but of the universe's greatest mystery, dark matter. Everything we have ever seen, from the smallest pebble to the brightest galaxy, is made of ordinary matter, the stuff that interacts with light. Dark matter is the opposite. It does not emit, absorb, or reflect any form of light or radiation. It is completely transparent, utterly invisible across the entire electromagnetic spectrum. Its presence is only felt through its immense gravitational pull, the ghostly hand that guides the motion of galaxies. A dark matter star, then, will be a colossal sphere of this invisible material. It will not undergo nuclear fusion like our sun, for there will be no atomic nuclei to fuse. Instead, its incredible gravity might pull in and annihilate regular matter, or perhaps the dark matter particles themselves could interact and release energy in a way we do not yet understand. The result would be a source of power and gravity that emits no light whatsoever. If one were to drift right past our solar system, it would be utterly undetectable to our eyes and our telescopes. We would only know it was there if we saw its gravitational influence, perhaps bending the light of distant stars or pulling on the orbits of our planets. This phantom is a reminder that the true nature of the cosmos might be written in a language of shadows, a script we are only just beginning to decipher. A star's own light can become its perfect camouflage. When a massive object like a galaxy cluster or a black hole lies directly between that star and our telescopes, its immense gravity warps the very fabric of space around it. This turns the cosmos into a funhouse mirror, bending the starlight that tries to pass through. The phenomenon is called gravitational lensing, and in its most extreme form, it does not create a beautiful, magnified ring. Instead, it shreds the star's image completely. The pinpoint of light we expect to see is stretched and smeared into a faint, ghostly arc across the sky. Its brilliance is diluted over such a large area that it simply fades into the background glow of the universe, becoming an undetectable blur. In other cases, the gravity might split the light into multiple distorted copies of the star, each one so faint and warped that it is unrecognizable. We would never know a single coherent sun was there. The very force that makes the universe visible, gravity, has instead rendered this star invisible, lost in a hall of mirrors made of space and time. Sometimes the very cradle that gives a star life becomes its perfect prison. Deep within a stellar nursery, a new sun ignites, its nuclear furnace bursting to life. But this young star is immediately swaddled in the thick, swirling disk of gas and dust from which it was born. This is not a thin, wispy ring. This circumstellar disk is a dense, tumultuous whirlpool of material, a chaotic construction zone where future planets are beginning to clump together from the cosmic debris. From our distant vantage point, the star at the center is completely smothered. The thick shroud of dust and gas absorbs the star's brilliant visible light, blocking it entirely. It is like trying to see a light bulb through a wall of thick black felt. The star is there, shining with the energy of fusion, yet its most defining characteristic, its visible glow, is utterly erased by the very substance that created it. We cannot see it with any optical telescope, no matter how powerful, but nothing in the cosmos is perfectly sealed. While visible light is trapped, longer, less energetic wavelengths can sometimes fight their way through the dusty chaos. Infrared radiation, which we perceive as heat, can leak through gaps in the disk. Our most advanced space telescopes are designed to detect this faint thermal whisper. So we know the star is there not by its light, but by the warmth it imparts to its dusty cage. We infer a brilliant newborn sun from the faint glow of the material hiding it, a cosmic paradox where the evidence of a star's existence is the very thing that keeps it invisible. The center of our own galaxy holds a secret it will not easily surrender. Buried within the brilliant, chaotic core of the Milky Way lies a star completely hidden from our view, not by distance or darkness, but by a cosmic crowd. This is the galactic center star, a sun lost in plain sight. Our solar system resides in the galaxy's quiet suburban outskirts, but its true downtown is a place of unimaginable density. Tens of millions of stars are crammed into a relatively small space, all orbiting the supermassive black hole known as Sagittarius A*. The combined light from this stellar metropolis creates a permanent, blazing fog. Trying to pick out one individual star from that glare is like trying to hear a single whisper in a roaring stadium. Its unique signature is simply drowned out by the collective shout of its neighbors. But the light is only half the problem. Between us and the galactic center stretches a 26,000 light-year journey through one of the dustiest regions of the Milky Way. This interstellar dust is not like household dirt. It is a haze of microscopic carbon and silicate grains, a fog so thick it blocks almost all visible light. The star's beautiful, familiar glow is absorbed and scattered by these trillions of tiny obstacles long before it can ever reach our telescopes. We are trying to see a single street lamp through a dense, perpetual blizzard. So how do we even know this hidden star exists? We listen to its other voices. While its visible light is imprisoned, other forms of radiation can punch through the dusty veil. Infrared light, which we perceive as heat, has a longer wavelength that can slip between the dust grains. Our powerful space telescopes are designed to see this thermal signature, revealing the star not as a point of light, but as a faint smudge of warmth. In some cases, we might detect its radio waves or X-rays, other frequencies that can penetrate the cosmic smog. We know the star is there because of its ghostly echo, a heat signature trapped behind a brilliant, impenetrable wall. It is a resident of the most crowded and violent district in the galaxy, living its entire life completely invisible to our eyes, a hidden neighbor in our own cosmic home. Some stars do not just wander, they flee. A hypervelocity star is a cosmic fugitive, ejected from the Milky Way at speeds so immense they defy gravity itself. These are not the gently drifting rogues we met earlier, cast out by galactic collisions. These are individual stars that have been shot out of the galaxy like a bullet from a gun, moving at over 1,000,000 miles per hour. At that velocity, the galaxy's immense gravitational pull, which holds billions of suns in orbit, is not enough to reel them back in. They are on a one-way trip into the absolute emptiness of intergalactic space, never to return. The sheer speed of their departure is what ultimately seals their fate as hidden stars. As they race away, the light they emit undergoes a dramatic transformation known as redshift. The wavelengths of their light are stretched out, making them appear redder and, more critically, much fainter to our instruments. They are not just moving away, they are vanishing before our eyes, their light diluted by the expanding universe and their own incredible velocity. Combined with the growing distance, this redshift effect makes them among the most difficult objects to track. We might catch a fleeting glimpse as they are ejected, a bright streak against the galactic core, but that image quickly fades. They become faint red ghosts receding into a void so vast that their signals are eventually lost to us entirely. They are travelers on a journey with no end, their stories fading into silence as they cross the final frontier. There's a type of cosmic cloud that acts less like a cradle and more like a tomb. A dark nebula is a cold, dense congregation of gas and dust, so thick and opaque it blots out the sky behind it. These are not the glowing, colorful nebulae we often see in photographs. They are voids of black silk stitched across the star fields, perfect silhouettes against the Milky Way's glow. And hidden deep within one of these light-devouring clouds can be a star. This is not a star in its infancy, swaddled in its birth cloud, but a fully formed sun that has, through its galactic travels, wandered into this pitch-black fog. Once inside, the star's fate is sealed. Its brilliant, life-giving light, the very essence of its identity, is immediately absorbed by the trillions upon trillions of microscopic dust grains that make up the nebula. The photons that have traveled for years from the star's fiery surface are swallowed whole just a short distance away, their journey ended by a wall of cosmic soot. At optical wavelengths, the very light our eyes are built to see, the star simply ceases to exist. It becomes a ghost, its presence implied only by the profound blackness of the nebula itself, a perfect sphere of nothingness where a sun should be. We could point the most powerful optical telescope directly at it and see only an impenetrable curtain of black, yet as with so many cosmic phantoms, its invisibility is not absolute. The star still radiates heat, and that heat warms the very dust that hides it. This causes the dark nebula to glow faintly with a warmth we can detect as infrared light. So while our eyes see only a hole in the heavens, our telescopes can sometimes perceive the thermal outline of the prisoner within, a star shining brightly in a spectrum of darkness, forever hidden behind the veil it inadvertently illuminates. A star can be bound to its own destroyer. This is the fate of a sun locked in a tight, ferocious orbit with a stellar mass black hole. The black hole itself is the ultimate void, a point of infinite density from which no light can escape. It emits nothing, a perfect puncture in space-time, yet its presence is betrayed by the star it torments. The two partners whirl around each other in a dizzying dance, their gravitational embrace so close that the black hole's immense pull begins to strip material directly from the star's outer layers. This stolen gas does not fall straight in. Instead, it spirals around the black hole, forming a superheated, glowing disk of plasma, known as an accretion disk. This disk is a maelstrom of friction and magnetic fields, shining with the intensity of thousands of suns across the X-ray spectrum, and in this violent embrace, the star itself can vanish. The brilliance of the accretion disk can become so overwhelming that it completely outshines the star's own visible light. The star is still there, a massive ball of fusing hydrogen, but its familiar glow is washed out by the incandescent fury of its own material being torn away and vaporized. From our distant vantage point, we might only see the blazing, flickering X-ray signature of the accretion disk, a beacon of destruction that hides the very source of its fuel. We infer the star's existence only by the regular dimming and brightening of that X-ray light, the telltale sign of an orbital period, a silent scream from a partner we cannot see, forever circling the darkest object in the universe. Long before galaxies took shape in a universe still raw and new, burned the very first suns, these are the population 3 stars, the pioneers of light. They were not like our own sun, a rich mixture of elements forged in earlier stellar furnaces. They were pure, composed of nothing but the 2 elements that existed at the dawn of time, hydrogen and helium. This pristine composition made them fundamentally different from any star we can observe today. Without heavier elements to help radiate heat away, the first stars had to grow to immense sizes to begin the process of nuclear fusion. They were behemoths, likely hundreds of times more massive than our sun. Their brilliance was staggering, shining with the ferocious intensity of millions of our own suns. Yet this glory was tragically brief. Burning their nuclear fuel at such a furious rate, their lifetimes were cosmically short, perhaps only a few million years. They lived fast, died young, and in their spectacular deaths, they forever changed the cosmos. Each one ended its life in a cataclysmic supernova or by collapsing directly into a black hole. These violent explosions were the cosmic forges that, for the first time, cooked hydrogen and helium into the heavier elements essential for life, like carbon, oxygen, and iron. They seeded the universe with the very materials that would one day form planets, oceans, and us. So why are they hidden? We have never seen a single population 3-star, and we likely never will. They all died billions of years ago, their light long since faded into the cosmic background. Our most powerful telescopes peer back in time, but they cannot see far enough to catch the brief, brilliant flash of these first suns. They are ghosts in the truest sense, their existence inferred only by their legacy. We see the elements they created scattered throughout the oldest stars we can find. We see their influence in the large-scale structure of the universe, but the stars themselves are lost to time, the vanished architects of everything that followed, forever hidden in the deepest layers of cosmic history. Our reality may be a mere slice of a far grander cosmic structure. String theory, a frontier of physics, suggests the universe could be built upon tiny, vibrating strings of energy, and that these strings require more than the 3 spatial dimensions we experience. They propose the existence of extra, curled-up dimensions too small for us to perceive directly. Within this framework, a truly alien possibility emerges, a star that burns in a higher spatial dimension. This would not be a star hidden behind a cloud or lost in a crowd. It would be a sun whose very existence is projected into a reality we cannot access. Its light, the photons it emits, would travel through these higher dimensions. The light would never enter our 3-dimensional space and therefore could never strike our telescopes or our eyes. It would be a source of illumination that casts no shadow in our world. Similarly, its gravity, the warping of space-time it creates, would be diluted across these extra dimensions. The familiar, predictable pull of gravity we know from stars in our universe would be absent. We would feel nothing. This star would be fundamentally, perfectly hidden. It could be right next to our solar system, occupying the same point in space as our sun, yet we would be utterly unaware of its presence. It is a phantom not of distance or darkness, but of dimensionality, a brilliant fire burning in a room we have no door to enter. Deep in the interstellar void, far from the warmth of any sun, drifts a world that blurs the line between planet and star. This is an ice-encrusted rogue, a colossal sphere of gas many times more massive than Jupiter, yet it failed to ignite as a true star. It formed in some forgotten stellar nursery, only to be flung out into the perpetual night, and its journey has transformed it into one of the darkest objects imaginable. Isolated in the deep freeze of space where temperatures plunge close to absolute zero, a profound metamorphosis occurs. The very gases of its atmosphere, like methane and ammonia, begin to freeze solid. They condense into crystalline snow and settle, layer upon layer, building a global crust of ice miles thick. This is not the bright, reflective ice of a frozen lake. This is a crust forged in an endless, sunless winter, a surface devoid of any cleansing sunlight or internal geological heat. It becomes pitted, dark, and incredibly porous, like a cosmic sponge made of soot-blackened frost. This ice does not sparkle, it absorbs, it captures any stray photon of light that might, by a 1 in a billion chance, strike its surface, swallowing it whole. The object becomes a nearly perfect black body, reflecting almost no light back into the void. It is a shadow, darker than charcoal, drifting unseen through the darkness. We could never spot it by looking for a glint of starlight, for it offers none. Its only signature would be a faint, faint whisper of warmth, the minuscule amount of heat left over from its violent birth, leaking out as a whisper of infrared radiation against the even colder background of space. It is a ghost world, a frozen testament to what happens when a failed star is sentenced to an eternity of cold, its fiery potential locked away beneath a shell of perfect, light-devouring ice. The final act of a star's life is not always a clean break. When a truly massive sun exhausts its fuel, its core collapses under its own immense weight, triggering a supernova explosion that can outshine an entire galaxy. For a brief, glorious moment, the star tears itself apart, blasting its outer layers into space at millions of miles per hour. This creates the beautiful, expanding nebula we often see, a glowing shroud of stellar debris. But what is left at the very center? Sometimes the answer is not a rapidly spinning pulsar or a ravenous black hole. Sometimes the collapse results in something far more silent and strange, a post-supernova ghost star. This is the cold, collapsed core of the progenitor star, a cinder that failed to cross the threshold into true neutron star density or to collapse into a true singularity. It is an object caught in a state of cosmic limbo, possessing immense mass packed into a sphere perhaps only a few dozen miles across, yet generating no new energy. Its nuclear fires are completely extinguished. It does not pulse with radio waves. It does not power a brilliant accretion disk. It simply sits there at the heart of its own spectacular funeral shroud, radiating only the faintest whisper of residual heat from its cataclysmic birth. This heat is so minuscule and the surrounding nebula so vast and bright that the ghost star is completely drowned out. We see the beautiful, glowing aftermath of the explosion, but the very engine of that destruction, the collapsed core, is a dark, cold void at the center of the light show. It is the ultimate cosmic irony, a star that announced its death with the loudest possible shout, only to leave behind a phantom that refuses to make another sound. One star can devour another, hiding it from the universe in a luminous prison. Near the end of its life, a star like our sun swells into a red giant, expanding its outer layers millions of miles into space. In a binary system, this expansion can be a death sentence for its smaller companion. The giant's tenuous but immense atmosphere, a roiling sea of incandescent gas, simply washes over the smaller star, engulfing it completely. The companion does not collide with a solid core. Instead, it finds itself orbiting within the outer envelope of the giant, a tiny, dense pearl lost inside a vast, luminous fog. From our distant perspective, the smaller star vanishes. Its light, a steady beacon in the visible spectrum, is immediately absorbed and scattered by the trillions of gas particles that now surround it. Every photon it emits is captured by the colossal star that has swallowed it, its unique signature blended into the overwhelming, ruddy glow of the giant. We see only a single aging star, its light flickering and shifting in ways we cannot fully explain, with no visible hint of the captive sun spiraling within its heart. This hidden star continues its doomed orbit, trapped in a furious dance against a drag of stellar material that will eventually spell its end. It may slowly spiral inward, transferring energy and stirring the giant's interior, or it might eventually be vaporized by the intense heat. For now, it is a ghost in the machine, a secret engine buried within a dying sun, its presence known only by the subtle, silent toll it takes on its captor's long, final journey. Perhaps the ultimate way to hide a star requires not cosmic chance, but cosmic intelligence. Consider a civilization so advanced that its energy needs dwarf our own, a culture that has learned to harvest the entire output of its sun. To achieve this, they might construct a Dyson sphere, a hypothetical megastructure of colossal scale that completely envelops the star. This is not a solid shell, but a vast swarm of orbiting platforms or collectors, a dense technological net designed to capture every single photon of light and every joule of heat the star produces. From the outside, the result is utter darkness. The star's brilliant light, the very signature of its existence, is absorbed by the swarm and converted into usable energy for its builders. No visible light escapes, no infrared radiation, no ultraviolet, nothing. The star vanishes from the electromagnetic spectrum entirely, replaced by a perfect, cold sphere of black. We would not see a star at all, only a patch of empty space that is strangely, unnaturally dark, a hole in the star field where a sun should logically be. Our telescopes would scan that region and find nothing but a void of profound absence that betrays a staggering presence. The only clue to its existence might be a faint, anomalous warmth, a tiny amount of waste heat leaking from the megastructure that would make this dark sphere glow ever so slightly in the far infrared against the cold background of deep space. This hidden star would be the ultimate monument to a civilization's power, a sun transformed into a private battery, its light extinguished from the galactic community, a secret kept on a stellar scale. There's a place in our galaxy where stars are packed together with a density that defies all intuition. Deep within the ancient spherical swarms known as globular clusters, the core becomes a stellar beehive. Here, tens of thousands, sometimes even millions of stars are crushed into a region of space that would barely extend past our sun's nearest stellar neighbors. The distances between them are not measured in light years, but in trillions of miles, a proximity that would turn their collective night sky into a permanent, searing daylight. In this brilliant chaos, a single ordinary star is born, lives and dies, yet we will never see it as an individual. Its light is lost in the crowd. Our most powerful telescopes, like Hubble, point towards these clusters and see not a collection of distinct points, but a single blazing ball of unresolved light, a glowing fuzz where 100,000 suns have merged their voices into one indistinct shout. The star is hidden not by darkness, but by an overwhelming excess of its own kind. It is a cosmic needle in a haystack made of other needles, all shining with the same intense light. To isolate its unique signature from that brilliant, churning core is like trying to pick out one single voice in a roaring choir of 100,000. The technology simply does not exist. This star will live out its entire life, perhaps for billions of years, as a nameless constituent of a greater whole, its identity forever subsumed by the sheer, dazzling power of the collective. This cosmic embrace creates one of the most peculiar engines in the universe. A Thorn-Zit-Cow object appears from the outside as a normal, if slightly unusual, red giant or supergiant star. It swells to an immense size, its cool, tenuous outer layers glowing with a familiar ruddy light. There is no visible hint of the secret it contains. But deep within its heart, where a star's nuclear furnace should be, lies something entirely different, a neutron star. This is not a binary system where two stars orbit each other. This is a stellar cannibalism of the most intimate kind, where one star has fully consumed the other, and the dense corpse of the victim now serves as the core of the predator. The neutron star, a city-sized object more massive than our sun, orbits at the very center of the giant, plowing through its gaseous interior. The external appearance is a perfect disguise, a brilliant masquerade that completely hides the exotic, ultra-dense reality within. We would look at this star and classify it as just another aging giant, never suspecting the cosmic paradox ticking away inside. So how does such a strange hybrid even form? The most likely path begins with a closed binary system, where a massive star and a neutron star orbit one another. As the massive star nears the end of its life, it swells into a red supergiant, its outer atmosphere expanding until it envelops its tiny, dense companion. The neutron star is now trapped, spiraling inward through the supergiant's envelope, its journey slowed by the drag of the surrounding gas. It does not immediately collide with the giant's core. Instead, it settles into a slow, decaying orbit, eventually coming to rest at the center, becoming the new heart of the star. The energy dynamics inside are unlike anything in a normal star. The intense gravitational field of the neutron star and the heat from its surface create a unique environment where unusual nuclear processes can occur. The giant's hydrogen-rich gas, raining down onto the neutron star's surface, might trigger exotic fusion reactions that produce elements like lithium, molybdenum, and rubidium in abundances that would be impossible in a standard stellar core. This is the object's potential telltale signature, a chemical fingerprint in its spectrum that screams something is profoundly wrong inside this seemingly normal giant. Finding that fingerprint is our only hope of uncovering this stellar imposter, a star that looks like any other but hides a cosmic secret in its core, a ghost from a past cataclysm now powering a brilliant, deceptive facade. This universal curtain of light is the cosmic microwave background, the oldest photograph in existence. It is the cooled and stretched remnant of the very first flash that filled the infant universe, a time when space itself was a searing plasma too hot for light to travel freely. When the universe finally cooled enough for atoms to form, that primordial light was set free, and it has been traveling ever since, now reaching us as a faint, cold whisper from every direction in the sky. It is the foundational glow of creation, and it forms an impenetrable wall. To see what lies beyond it is not a matter of building a bigger telescope. It is a fundamental limit of observation, a horizon in time itself. Any starlight from before this moment, from the very first generations of stars that might have ignited in that raw, early cosmos, is forever trapped behind this wall. Their light cannot reach us because the universe itself was opaque before this point. The photons from those first hypothetical suns would have been scattered and absorbed by the dense, hot plasma of the early universe, their information lost and blended into the uniform glow of the background itself. We are looking at the ultimate cosmic fog. Imagine standing in a dense, brilliant fog so thick you cannot see your own hand. Now imagine that this fog is not made of water, but of light itself, a uniform, all-encompassing radiance that blocks your view of everything behind it. That is the cosmic microwave background. It is the final curtain, drawn across the stage of the universe at the moment of its greatest transformation. We can study this curtain in incredible detail, mapping its tiny fluctuations to understand the seeds of all future structure, but we can never pull it aside. The stars that lived and died in the universe's first fiery moments are the most hidden of all, their individual stories permanently erased, their light blended into the single, universal hum of our cosmic origin. Even the most isolated star we can find today still shares a universe with others, a faint glimmer in the vast cosmic web. But there is a fate more final, a loneliness so absolute it defies our very understanding of existence. Drifting in one of the universe's great voids, a vast and nearly empty expanse where galaxies are few and far between, is a star whose future is one of ultimate isolation. This is not the emptiness between stars in a galaxy, nor even the gulf between galactic clusters. This is a cosmic desert on the grandest scale, a region where the average density of matter is almost zero. Here a solitary sun burns, its light a tiny beacon in an immense dark ocean. For now it is still tethered to the rest of the cosmos by the thin, gravitational threads of the few distant galaxies that speckle its sky. But this connection is temporary, and its severance is guaranteed by the most mysterious force in the cosmos, dark energy. This is not a force like gravity that pulls things together. Dark energy is a property of space itself, causing the very fabric of the universe to expand at an ever-increasing rate. In the dense urban centers of galaxy clusters, gravity fights this expansion to a standstill, holding its cosmic cities together. But out here in the void, there is nothing to fight it. The expansion is unchecked and accelerating. With every passing moment, the distant galaxies that form the backdrop to this star's existence are carried away faster and faster. Their light, already redshifted and faint, will become progressively dimmer. There will come a moment, billions of years from now, when the expansion of space between this star and all other galaxies will be happening faster than the speed of light. This is not because the galaxies are moving through space that fast, but because the space between them is itself stretching at an unstoppable rate. When that threshold is crossed, the light from those galaxies will no longer be able to cross the growing chasm. They will, from the perspective of this lone star, vanish one by one. The last distant pinprick of light will wink out, and the observable universe for this star will shrink to a perfect, unbroken blackness. It will be the only thing left in its sky. No new light will ever arrive. No future civilization, no matter how advanced, could ever build a telescope powerful enough to see it, for the photons it emits will never reach another galaxy, and no photons from another galaxy will ever reach it. It will become a star in a universe of one, a prisoner in a cell whose walls are made of expanding space, forever hidden not by distance, but by the fundamental and irreversible acceleration of reality itself. Deep within the cosmic graveyard, a sleeping giant waits. This is a magnetar, a neutron star born from stellar catastrophe, possessing a magnetic field of almost unimaginable power. During its active phases, such a star is a cosmic terror, its magnetic field so strong it can rip molecules apart from a distance of 100,000 miles, cracking its own crust in starquakes that release flares of gamma rays visible across the galaxy. But there is another state for these monsters, a quiet, dormant phase known as hibernation. In this deep sleep, the magnetar emits little to no radiation. Its furious spin has slowed over millennia, its intense X-ray and gamma-ray outbursts have ceased, and its surface grows cold and dark. The very forces that make it a beacon of destruction are temporarily switched off. It becomes a ghost of its former self, a sphere of ultra-dense matter adrift in the void, its unimaginable magnetic potential locked away and invisible. We could point our most sensitive telescopes directly at it and register almost nothing, a profound silence where a cosmic scream should be. Its magnetic field, a trillion times stronger than Earth's, is still there, warping the very quantum vacuum around it, but with no energetic outburst to announce its presence. It is nearly impossible to find. This dormant monster is a reminder that the most terrifying powers in the universe can sometimes be the quietest, biding their time in the dark, waiting for a moment we cannot predict to wake and remind the cosmos of their strength. Our sun's brilliant light comes from the violent fusion of atoms at its core, but what if a star could shine from something far more mysterious? The speculative concept of a dark matter annihilation star proposes exactly that, a celestial body powered not by nuclear fusion, but by the self-destruction of its own substance. Imagine a vast sphere, not of hydrogen and helium, but composed almost entirely of dark matter. At its core, the density of these invisible particles would be so immense that they would constantly collide and annihilate each other. When a particle of dark matter meets its antimatter counterpart, they would obliterate one another in a flash of pure energy, following Einstein's famous equation. This steady, relentless release of energy would replace the nuclear furnace of a normal star, providing the outward pressure needed to keep the star from collapsing under its own weight. The light and heat generated will be the byproduct of this continuous annihilation process, so why would such a star be hidden? Its energy signature will be profoundly alien. A fusion-powered star like our Sun emits a predictable spectrum of light with a specific balance of colors and intensities that we understand. A dark matter star, however, might glow with a very different and much fainter light, perhaps concentrated in wavelengths our eyes and telescopes are not optimized to see. It could be an ultra-diffuse, ghostly object, radiating most of its energy in exotic particles, or a subtle, uniform warmth that blends seamlessly into the cold background of space. We might look directly at it and mistake it for a wisp of nebular gas or a faint, distant galaxy, completely missing the fact that we are seeing a single, coherent star built from the universe's greatest secret. This phantom represents a universe operating by rules we have only begun to guess, where the invisible fabric of reality itself can ignite into a hidden sun. Even the ultimate fossil of a star is not truly eternal. A black dwarf, that cold, crystalline sphere of carbon and oxygen, seems like the final, silent end of a stellar story. But across time scales that dwarf the current age of the universe, even this dark sentinel is subject to the bizarre laws of the quantum realm. The stability of the black dwarf is an illusion on the grandest of clocks. Its atomic nuclei, the protons and neutrons that have been locked in place since the star's active life, are not perfectly immutable. Quantum tunneling introduces a tiny, almost impossible probability that the particles inside the black dwarf can spontaneously achieve something extraordinary. A proton, one of the fundamental building blocks of all matter, could simply decay. This is not a violent explosion, but a quiet, undetectable flicker, a transformation into lighter particles and a burst of energy so minuscule it would be lost in the cosmic background. For a single proton, the predicted half-life is staggering, perhaps longer than a 1 followed by 34 zeros years. Now, multiply that by the septillions of protons that make up the entire star. The black dwarf would begin a process of slow-motion evaporation. Over these near infinite eons, the star would not glow or radiate heat in any conventional way. The energy released from each individual proton decay would be infinitesimal, a whisper of radiation swallowed by the vast, cold darkness. The star's immense mass would gradually, imperceptibly diminish. It would not shrink in size, but its substance would be slowly converting into a faint ethereal energy, leaking away into the void. Long before the final proton decays, the black dwarf would have passed a threshold of detectability. It would become so diffuse, its remaining mass so faint, and the process so slow that it would effectively vanish from the universe's inventory long before it physically disappeared. It transitions from a dark object to a ghost, and then from a ghost to a memory, its final evaporation a silent, unobserved event in a cosmos that has long since forgotten what a star even was. Some cosmic structures are not content to simply surround a star. They create a cage of dust and shadow aligned with the star's very axis of rotation. This is the hidden star trapped within a polar dust disk. Imagine a star with a colossal, thick belt of dust, but instead of wrapping around its equator like Saturn's rings, This belt is tilted 90 degrees. It forms a dense, opaque torus that encircles the star directly over its north and south poles. From our specific vantage point on Earth, if we happen to be looking directly through the plane of this disk, the star at the center is completely erased. The countless trillions of dust grains in that edge-on disk absorb every bit of the star's visible light, creating a perfect vertical bar of blackness that slices across the star's location. We would see only a dark silhouette, a star-shaped hole in the sky that our optical telescopes cannot penetrate. The star itself shines brilliantly, but its light is funneled out through the open poles above and below the dusty disk, creating two opposing cones of radiation that shoot into space. If we are not positioned within the narrow path of those cones, we see nothing at all. This is not a star hidden by random chaos, but one concealed by a precise and stable geometric prism. Its light is not dimmed, it is directionally filtered, beamed into the cosmos like a lighthouse whose rotating beam never, ever points in our direction. We know such structures exist because we see their shadows cast against brighter nebulae behind them, or we detect the faint infrared glow of the warm dust that forms the cage. The star itself, however, remains a brilliant secret, its full glory visible only from a perspective the universe has denied us. There is a final whisper before the collision, a tremor in space-time itself. Two neutron stars, the ultra-dense corpses of massive suns, are locked in a fatal embrace. They orbit each other in a region of space that appears utterly black and empty to every telescope we possess. No visible light escapes their vicinity, no X-rays, no radio waves. The environment around them has been scoured clean by past supernova or shrouded by dust, leaving no material to glow in their fierce gravitational grip. There are perfect phantoms, invisible across the entire electromagnetic spectrum, yet they are screaming their existence into the void. As these incredibly massive objects spiral closer and closer, their orbital dance accelerates and they warp the fabric of the universe around them. This warping creates ripples that propagate outward at the speed of light, gravitational waves that stretch and squeeze space itself as they pass through it. These are not waves of light or sound, but distortions in the fundamental geometry of reality. For the vast majority of their death spiral, this faint, rhythmic stretching is the only signal they broadcast. Our most sensitive instruments like LIGO and Virgo are designed to listen for these cosmic tremors. They use lasers to measure minute changes in distance, changes smaller than the width of a single proton, caused by a passing gravitational wave. The signal is a distinctive chirp, a rapid increase in the frequency and amplitude of the waves as the stars hurtle toward their final union. For years or even centuries, this invisible binary could be emitting this silent siren song, completely hidden from our eyes and all our conventional telescopes, known only by the subtle shiver it sends to the cosmos. It is only in the very last seconds of their lives, when they finally smash together, that the cataclysm might tear open the darkness. The collision could create a flash of light, a kilonova, that briefly outshines a galaxy, finally revealing the location of the phantoms. But until that final, violent moment, they are ghosts, known only by the echo of their motion in the silent fabric of space. Our own solar system holds a secret alignment that permanently hides a distant sun. A star exists in a direct line behind our own, its light completely drowned out by the overwhelming glare of our day star. From our fixed perspective on Earth, this cosmic neighbor is always positioned in the same patch of sky as the sun itself. We can never point a telescope in its direction, because that would mean staring directly into the sun's blinding light, an act that would instantly damage the most sensitive instruments. This is not a matter of distance or technology. It is a simple, permanent trick of celestial geometry. The sun's brilliant corona and the intense scattering of light in our own atmosphere create a wall of pure illumination, washing out the faint, distant pinprick of that other star. It is perpetually lost in the glare, a hidden companion whose existence we can only infer from other data. We know it must be there because our maps of the galaxy are three-dimensional. By studying the motions and positions of other stars, we can deduce that a sun occupies that specific coordinate in space, even though we can never observe it directly from our home planet. This star lives in our sun's permanent shadow, a cosmic blind spot dictated by our own location in the universe. It is a reminder that some of the universe's most fundamental secrets are hidden not in the distant voids, but in the most obvious, brilliant places we are conditioned to ignore. A rogue star's journey of ultimate solitude could find an unexpected end in the outer reaches of a remote solar system. Far from the warmth of the inner planets, an ice giant like Neptune drifts in the perpetual twilight, a colossal sphere of frozen hydrogen and helium wrapped in a deep, turbulent atmosphere. This planet's gravity, immense on a planetary scale, could act as a cosmic net, ensnaring a passing rogue star that ventured too close. The star would not crash into the planet. Instead, it would be pulled into a wide, looping orbit, becoming a permanent, hidden captive of the world it now circles. From our vantage point, the star's light is erased by a perfect combination of obstacles. The ice giant's thick, methane-rich atmosphere, a swirling blue haze of hydrocarbon crystals, acts as a brilliant, reflective cloak, scattering and absorbing the star's visible light. The sheer distance from our solar system further diminishes its signal, reducing it to a faint, untraceable flicker against the cold backdrop of space. We would observe only the ice giant, a solitary blue dot in the void, with no visible indication of the brilliant sun held in its gravitational thrall. This captured star would orbit in a silent, perpetual dance, its light forever smothered by the atmosphere of its captor, a prisoner of gravity in the frozen dark of an alien solar system. The universe's most fleeting star does not live for billions of years, but for less than a heartbeat. Born from the raw, seething energy of empty space, the quantum fluctuation star is a testament to the bizarre laws that govern reality at its smallest scales. According to quantum mechanics, a perfect vacuum is not truly empty. It is a turbulent sea of potential, where pairs of particles and their antimatter counterparts constantly blink into and out of existence, borrowing energy from the void for a moment before annihilating each other to pay back the debt. This chaotic dance is the quantum foam. On an unimaginably rare occasion, a fluctuation could be so vast and energetic that it spontaneously forms an entire, fully functional star. This is not a star that forms from collapsing gas. It is a star that simply appears, a fully realized sphere of fusing plasma that materializes from absolute nothingness. Its nuclear heart ignites the instant it is born, shining with the light of a true sun. But this miracle of physics is tragically brief. The energy loan that created it must be repaid almost immediately. The star exists for a time so short it defies human perception, perhaps only a few Planck times, a duration so minuscule that there are more of these units in a single second than there have been seconds since the Big Bang. Then as suddenly as it appeared, it vanishes. The star and its antimatter twin annihilate in a silent flash, returning every bit of mass and energy back to the void from which they came. It leaves no trace, no expanding nebula, no gravitational echo. The entire event from birth to death is over before a single photon from its surface could travel a meaningful distance. No instrument we could ever build will be fast enough to catch its fleeting glow. It is a cosmic firefly that flashes once in absolute darkness, its existence a secret known only to the laws of physics themselves, a phantom so transient it barely qualifies as real, yet its theoretical possibility hints at a universe where reality itself is a constant, shimmering illusion. From the silent, drifting rogues to the brilliant stars lost in galactic crowds, we have journeyed past 30 cosmic phantoms. Each one reveals a different method of vanishing, a unique reason for its secrecy. There are failed stars frozen in ice, ancient giants hiding neutron hearts, and theoretical suns burning in dimensions we cannot perceive. Some are hidden by darkness, others by light, and some by the sheer, irreversible expansion of the universe itself. This incredible variety proves that what we see when we gaze at the night sky is only a tiny fraction of the whole story. For every brilliant point of light, there may be dozens of phantoms, each a testament to the vast, uncharted wilderness of the cosmos. These hidden stars challenge our perception of reality, reminding us that the universe is far stranger and more wonderful than it appears. So as the echoes of these stellar ghosts linger in your mind, consider which one captures your imagination the most. Was it the silent, sleeping magnetar, the star-devouring red giant, or the ultimate fugitive, the hypervelocity star on its endless journey into the void? The conversation about these cosmic secrets is just beginning. Share your thoughts on which hidden star fascinates you the most, and keep looking up, for the darkness holds more wonders than we will ever know.